Hi everyone, welcome to another session with Harita Hive. Today we will do the basic watershed delineation. So first of all, we need to understand what a watershed is, right? So let us just have a look. If you Google about watershed and look in the images, so for example here, you will find a watershed is the area of land that channels rainfall and groundwater to a common outlet such as a gut or and then to the sea. So what it basically means is it's a region where all the rainfall or the surface water or the groundwater, if it runs on the if it gets collected in the surface also, so all that water when it channelizes into a single output, okay, so that is called as a watershed. Now watershed can be used in many applications. It is used for flood modeling. It is used to understand the groundwater recharge. It is used to uh, it is used by disaster management authorities to understand how the risk of flooding in that region is, or for it can be used for agriculture purposes, right? So today we will understand how to delineate a watershed, how to calculate the area of a watershed, right? So the first basic thing that you need to do is simply go install your QGIS. So if you're new to GIS, just go on Google and look for QGIS. So in this website qgis.org, you can find a link to download the QGIS software. So this is an open source software to uh, work with GIS applications. Otherwise, if you have the access to ArcGIS Pro, that is also the same can also be done in ArcGIS Pro. Okay. Now, to work on a watershed, the first thing that you need is a digital elevation model. Okay. Now, we have covered what a digital elevation model is in our classes. But just to give you an example, a digital elevation model is a 3D reference of the relief of the surface or the terrain. Okay, so it looks like something like this. You can use different kind of colors to give it a symbology. Now, for our current case, we need to download a digital elevation model. We will understand how we can download a digital elevation model. So there are many sources to download a DEM. Okay, now a digital elevation model can be open source as well as proprietary. So if it is proprietary, it would be very high resolution and it would be obviously it is paid, right? Now if you're looking for free sources of digital elevation model, now there are some DEMs like, so if we ask Gemini, let us see. So it tells us some free sources, that is the SRTM DEM that is available on the USGS Earth Explorer. Then we have the Ester Global DEM. Now both of them are 30 meter in resolution. That is, one pixel on that DEM is the size of 30 meter by 30 meter. Then we have the JAXA ELOS World 3D. Now it is by the Japan Aerospace Exploration Agency. Then we have the Open Topography Copernicus Glow 30, Glow 90. Okay, and similarly there are many others. Now we have, for India, we have the Cartodem. Now I will show you how you can download a SRTM DEM, that is from the Earth Explorer. What you need to do is simply you have to go to Google, right here USGS Earth Explorer. Open the website. Now the first thing that you have to do is log in into this website. So the interface will appear like this, but do not forget to log in. Login is very important. So once you log in, if you don't have an account, you simply can find the create a new account button here. So it is very easy to create an account. And once you have created your account, just simply log in. To download a digital elevation model, first look for the location where you want to do your watershed analysis. So for example, if I'm looking for some area in India, what I can do is there is this option here that is US feature and world feature. So in the world feature, if you're looking for a place in US, you can just simply use it here and keep write the name here in the feature name. So for example, my location is in India. So I'm looking for the city Chandigarh. So I put in Chandigarh here and click on search. So adjacent to Chandigarh, there are the lesser Himalayas. We'll be doing the watershed analysis for them. So here you can see the location appears here. If in case the place is not available in the world feature, you can simply pan and zoom here. You can pan and zoom here to what location you are moving to. And if you have found your location in this search box, you can just simply click on it and you will get a place mark over your search place. Now, for example, if you switch to the world imagery here, you can easily visualize that this area is a hilly region, mountainous region, whereas it is moreover plain in this side. So to understand watershed better, it is to work with a DEM in a hilly region. Now you can simply choose the area and click on use map. Zoom a little out, you'll get the 4 place marks. You can move them around as per your requirement of the area. Okay, now if you have a predefined area, you can add the shape here, that is a KML or an SHP. You can make a circle with a radius, enter the latitude and longitude, it will be taken as the center point and you can create a circle around it, or simply again, as I said, you can create a place marks and then change it to your requirement. Right? So the next thing is to select a date range, but because here we are downloading a DEM, DEMs are rarely produced by the satellite agency. So I would suggest to leave it blank and you will have all the latest to the oldest DEM in your search bar. So just simply click on datasets and here you will find an option that is digital elevation. Click on it and in the sub domain of it you will find a SRTM tag. Just click on SRTM and in SRTM you will find SRTM 1 arc second global. So 1 arc second global means it is equivalent to 30-meter resolution. So just simply click on it and click on results. So for this region, you'll see the available DEM here. You can check the footprint of these DEMs by clicking on it. So for example, this DEM, it has the complete area in it. It would be more preferable for me, or you can. So if some other DEM has a sub area of it, then I have to download 2 or 3 DEMs and then merge it. Okay. So it depends on you how you want your data to be. Now, once you click on download, so for example, I find this DEM as preferable. You can simply click on the download button here and choose the GeoTIFF option and the DEM will be downloaded to your computer. Now, before we go ahead, we need to install one plugin in QGIS. That plugin is called as SAGA plugin. So you just simply look for the plugin in your in the head ribbon. Just look for the word plugin here. So just click this plugins and click on manage and install plugins. So an interface like this will appear. Here, look for SAGA. So you'll find something like processing SAGA next gen provider. Install this plugin. Now this plugin has to be installed in two steps. So one step is first you install the plugin here. Now as it says here, since QGIS 3.3 SAGA tools are not included in standard QGIS installation, in order to use SAGA tools in QGIS, you need to install the plugin first and then manually install this SAGA 9.2.0. So once your plugin is installed, then you need to visit this website here. Click on this website. Look for the latest version. So for example, the latest version is SAGA 9. Simply choose the latest 11.1 and here look on the setup based on your operating system. So for example, we are working with Microsoft Windows. So this is SAGA _ Microsoft Windows setup. So you can download this one. If you are working with a Mac, you need to download this one, right? So once it is downloaded, simply go to your processing toolbox, that is here, or you can click on processing and click on toolbox and write here SAGA. So SAGA next gen should appear here and you will find all the different sub plugins inside of it. Okay, all the different algorithms that are part of this SAGA plugin will be present here. Now once you install the SAGA plugin, the next step is to move forward with the DEM. Now what you can do is simply locate the DEM that you downloaded, drag it into your QGIS. So this is our digital elevation model. So in this digital elevation model, you can see here the lowest value that is available to us is 595 meters and this is 6124 meters. Now this is the height above the sea level. Okay, now the lowest elevation is 595, the highest is 6124. So the highest elevation is in this DEM is represented by white color. Now first we need to check the projection of this digital elevation model. So just right click and go to properties. So you can see that the projection of this digital elevation model is WGS 84. Now there is an important thing that you need to remember. Whenever you are working with a raster, okay, to not get errors, you need to first reproject it into your projected coordinate system. So currently it is in a geographic coordinate system and we need to project it into a projected coordinate system. Now if you know your projected coordinate system or the projected coordinate system of this region, well and good. Otherwise, how you can locate the projected coordinate system? What you can do is simply go to Google and write locate my UTM. Yes. So you will find this website, that is Mango GIS. Just click on this website and it will ask for your location. Allow this time. So for example, it located me, and you can see that I am in the zone UTM 43N. So the area that we have selected, it falls here. It is also in the 43N zone. So this is how you can locate your UTM projection system. Now I will reproject this raster layer into a UTM projection. Simply go to raster, choose the projection system and click on warp, that is the reproject. In reproject, select the original DEM. It is optional to choose the source DEM. Okay. Now the default or the project CRS is the default projection system, that is the geographic coordinate system WGS 84. Now I need to choose a target CRS. As I told you, we are converting it into a UTM projection. So simply click here. If your zone is listed here, then it is okay. Otherwise, just click on this option here, and here you can select this predefined CRS and you can look for your CRS. So for example, we are going to work with UTM 43N. So the zones are available here. So we select this UTM 43N. If you want to save this layer to your computer, what you can do is, at the end of it, you will find this option, that is reprojected. You can save it to your computer or save it to a temporary file. So by default, it saves to a temporary file. So we will go ahead with the temporary file and I will click run. So now I have a reprojected DEM. Okay. Visually you cannot understand what is the difference, but there is a difference. So if I turn it on off, you will see that the DEM actually shrinks a little. Okay, so there is an actual difference. Now I will remove this older DEM. Now the first step to create a watershed is to select and create the fill DEM. Now to do so, after installing the SAGA plugin, just simply go to the plugins, look for the Python, look for the processing toolbox. In this toolbox, you need to enter the fill sinks. So you will find an option here, that is the fill sinks. In raster terrain analysis. Also the same is available with the SAGA. You can simply, for now, you can use this, the inbuilt one for the QGIS. If you want to study more about what is fill sinks and about this, the authors Wang and Liu, their research paper is available on the internet. You can simply write fill sinks and search for Wang and Liu. So you will find the details about this in this SAGA module. Also you can look for their research paper. So this is the research paper that is available on the ResearchGate. If you are using them for your research purpose, you can cite this paper. Now simply click on this. If you want to save the just a moment. Yeah. For now we will work with the fill sinks available in the SAGA Next Gen. So double click on it. You will find that there is an option where filled DEM and other two things are also created along with it. We do not want watershed basins and flow directions for now. We will uncheck these two options. And if you want to save this fill dem, you can save it to your computer somewhere, okay, or you can use it just like a temporary file. So just check the option that is available with the fill dem. Now simply run it. It will take a little time to be created. So we have discussed what fill sinks actually is in one of our theory classes. So we are now having the fill dem available to us. Now there is not much difference between how they visually look, but technically there is a difference among the values. So we are going to use the fill dem for our application further. Now there is something that you need to understand before going ahead, that is the stream order. So if you look at this image, what is actually happening? The origin point where rainwater starts collecting, or it can be any kind of surface runoff, when it starts originating from someplace, maybe the glacier starts melting here, the snow starts melting here, okay, it is termed as 1. When two orders of degree, when two streams of order 1, when they connect, it forms a stream of order 2. So these are the orders of stream. So for example, if you see there is a mistake in this one. If you see 2 1s are connected here and it becomes a 2. Now when 2 2s are connected, it becomes a 3. When 2 3s are connected, it becomes a 4. So this is a stream order. Now this particular stream order is called as Strahler method. There are many different classifications for this stream order. The most widely used one is this Strahler stream method. So just make sure that you are clear about what a Strahler stream order is before you go ahead with the practical. Okay. Now since we have our fill dem here already, that is required for us to create a Strahler stream order. What we will search for is now the Strahler. So in SAGA NextGen, you'll again find that there is a Strahler order. Just simply click on it. Use the fill dem as the elevation. If you want, you can save this Strahler order to your computer. Simply click on run. So you will find that lots and lots of streams have been generated out of this filled dem. But because the stream as of the order 1 is not necessary for us, we will try to visualize this data again. So if you can see here, the stream order 1 to 10 is available. In the example that I just showed you, I showed you the stream order from 1 to 4. Okay. So just imagine here you have the stream order available, that is 1 to 10. That is why the branching, the network is so dense. So we will only select some of it, and we do it by the hit and trial method. Okay. Or it also depends on your application of use. So if you are working for flooding, maybe you have to consider all of the stream orders. If you are working just to understand how the area is, okay, then maybe a stream order above 3 will work. So it depends on your application of use, right? Now I will go to this raster here and click on raster calculator. So you will find the stream order available here. Simply click on the stream order, choose what it should be greater than. So let us, for example, choose the stream order maybe as 6, right? So this is a hit and trial. So we will see if 6 works or not. Maybe we have to change it to 7. Maybe we have to go low to 5. Okay. Save this layer. Make a name out of it. Just save it in your computer somewhere. Make sure the format is GeoTIFF and simply click on OK. So if you turn everything off and just turn out the, so above stream 6 is also very dense. There is another way to visualize it. Right click on it and go to properties. So in symbology, you will find in the render type, you will find the paletted and unique colors. Okay. Once you click on it, just click on classify. Choose the above one, right click on it, change its opacity to maybe 0. Now if I click apply, okay. So if I turn my demo on, so this is the stream order 6. So I think it works. You can also change it to maybe 5, maybe 4, then the network will get more dense. Okay. Now, because we just visualized it, and I think we can work with the stream order 6. If you want to make it a little more dense, what you can do is again, just go to raster calculator, choose Staller order greater than equal to 5, maybe save it as 5 and click on OK. So let us visualize how 5 looks. Right click on it, go to unique colors, classify, change opacity 0. So if you see the difference now, when I have taken 5 as the threshold, anything above 5, that is in red color. So it is more dense. The network is more dense. Whereas for 6, the network was not so dense. So if you want more dense network, you can choose 4, then 3, then 2. It depends on your application of use. Okay. So for now, for our current reference, let us work with 5 then. So once you are able to understand which stream order you are using, what you have to do is you need to look for something called as channel network and drainage basin. So simply go to your processing toolbox, look for channel network and drainage basin. Okay. So for now, let us just turn this off. And in channel network and drainage basin, uncheck all the options that you see. There are multiple things that will be by default created. We just want to create the channels. So just look for channels here. Yeah. So just look for channels here. If you want to save it to your computer, you can save it, right? You can maybe call it stream. So the output will be in the form of SHV. So first we actually visualized the stream order. So this was just the visualization. Now to actually produce this, we are using this channel network and drainage basin, right? simply select the threshold. So for example, we got to know that we will be working with 5 using hit and trial. So just select 5, select the option under the channel, give it a name, and simply click on run. This will take a little time. Okay, just a moment. Let us try again. Channel network and drainage basin. So the last option. Yeah. So one thing that I did wrong was here, I did not choose the correct elevation. So for elevation, you need to use the filled dem. Okay. So this is very important. That is why I did not get any result. Okay. So first we created filled dem, and in all of the whenever we are going to use the plugin for the SAGA next, we need to choose the filled dem for elevation. Okay. So let me click run now. So if you so you can easily visualize that I have the stream order above 5 here now. Okay. So if this is also another activity, like if someone is asking you to create a stream pattern of the area, you can use the dem to create a stream like this. Okay. So you can extract the stream using a dem. So this will also now be used to create a watershed. So once you have a stream network, you can change the symbology of it. Maybe let us make it blue. Choose a little much more width, right? Generally speaking, you can easily visualize with your own eyes how a watershed looks. So maybe if I'm looking for a small watershed, it could be this region. This could be one small watershed, because by definition watershed has one single outlet. Okay. Anywhere you find any point, if you place any point anywhere, if that is on a single outlet, it will form a watershed upslope. So this is one watershed. Maybe if I want to create a bigger watershed in this, at this point, so you can see it is branching out too big. Maybe the watershed then will be very big. So for example, if I take a watershed at this point, if I output analysis at this point, then the watershed will be just this much. What if I take the watershed analysis at this point? Then it will include all this area, right? So it depends on your choice of output point, where you want to have your output point. Based on that, the size of the watershed will be. Okay. Now, once you have created this, what you can do is, if anyone has any doubts, you can ask in the live chat. Okay, I'm also looking at the live chat. Now, simply go to your processing toolbox. As I said, we need to create one point somewhere. So to understand watershed wherever we can create it, we need to create a point. So what I will do is, let me create a new shapefile. So I will go to layer, create layer, new shapefile layer. Let me call it a point. Now I will select the geometry type as point. While I was teaching this same thing to one of the batches before, what I did wrong was, I forgot to choose the coordinate system as the same one of the raster. So even though my point, whenever I choose a point, maybe I choose a point here, in actual, because it belonged to some other coordinate system, it was not here. Though the placement was here, but because it was now the map has two different coordinate systems working there, then it was an error. So make sure that you choose the coordinate system same as the raster layer, that is the UTM-43N. Now simply click on OK. Now let us create a point somewhere. So I will simply go to this editing toggle button, click on it, create a new point. So for example, I see that this can be one big watershed here. Okay, let me select this point. So turn on the snapping so that you make sure that you select the point. If the snapping is on, maybe you are trying to select the point and you are unable to capture the points that long. So just turn on your snapping, click on that point. Now I've created this one point. Go to the attributes of this point. Go to the field calculator. We need to create two new fields. Okay. So let one field be latitude, that is the X. So the latitude is in decimals because it has a point values. So here in geometry, you will find an option that is $X. So this is used to evaluate the latitude of that point. So once you click OK, that new point will appear. Again, let us just create one more field. Go to field calculator, create new field, name it as longitude. Select a decimal. This time choose $Y. And press apply. So if you see, I have both X and Y coordinates of that point now. Simply click on the toggle and save the result. Okay. Now you need to go to the processing toolbox again and look for upslope. The name was, just a moment, upslope area. So just simply look for this one. It has the only name, that is the upslope area. Click on it. Select in the target area, you will find this option. Just a moment, sorry, leave this target area as blank. You can put the X and Y coordinates here. So if you see, just copy the X coordinate, put it here, copy the Y coordinate, choose the elevation as filled them and simply click on run. So if you see, a watershed has been created for our point, right? So this was the point that we selected. Now we have the output here. Okay. So simply you can create watershed for all the other available drainage pattern here. You can create a watershed here, maybe here, right? So let us create one or two more. Let us choose this point. Let us choose one more point. Now simply again we can go to the attribute table. You need to again go to the field calculator, update existing field, lat x, go to geometry, choose $x, click apply. Make sure that just not one layer is selected, so deselect it from here. So I have the X for all of them. Then again update existing field, choose the longitude, in geometry choose the $y. Okay, so let us try to create one another watershed now. Click on upslope area. So this time let us create for coordinate 2. Copy this, paste it here, copy the y coordinate, paste it here. In elevation choose the filled dem. Okay, now simply click on run. Now there is also this thing, these are different algorithms, that is the deterministic gate, infinity, multiple flow direction. Generally we are using deterministic gate. If you want to understand more about this, you can watch one of our recorded classes. Okay, so I have selected deterministic gate and simply run. Y is latitude and x is longitude and so this is the another watershed that I created for the point 2. Okay, similarly I can create one for the point 3. Now there is one important thing, that the watershed that we just created, it is in the form of raster. We need to vectorize it. Okay, so to vectorize it, what you can do is, so for example this was the upslope area 2, right? So this was the upslope area 2. Now to vectorize it, you can just simply go to raster, conversion, and choose polygonize. You can also find this option if you look polygonize here. So this is the option. Okay, now once you choose this option, save it to your computer if you want. Watershed. So this is also in the form of SHP. Now simply click on save and then run. Now you can visualize that this raster layer has been converted into a vector. Now mostly we are asked the area of a watershed. Okay, now to calculate the area of watershed is simply very similar to how we calculated the x and y coordinate. What you can do is right click on this watershed, open attribute table, add a field here. So you can call the field as a area. So area can be in decimals. In geometry, look for $area. Now because we want the area to be in kilometer squares, what you can do is you can divide it by 10 raised to power 6. Okay. Simply apply and click on OK. So you will find the area of the region now. So it is 496 kilometer squares. So this is the area, this is the drainage of this watershed. Now what you can do is just create some watersheds, create a map out of it. We learned in the last classes how to create a map. Now this was the practical part of it. Just to have a look how it can be used in GIS, or maybe let us search the uses of watershed. Okay. So if you see here, we can understand the areas where the incoming precipitation is received, right? Because it is also crucial for the health of the environment and ensuring sustainable development. It involves the process of managing and conserving the water resources within a watershed. Okay. So one thing I just want to say, this is the initial part of any flood modeling or numerical modeling that you want to learn. Now, if you want to learn, there are 3 other types of advanced modeling. So for example, there is SWAT model. So this is one of the advanced model that you can use to understand the flood modeling. There is HEC-RAS model. And then there is HEC-HMS. Recently Mike 11 has been used a lot. So another one is called as Mike 11 model. So these models are being used to understand the flooding events. Okay, how, for example, how a flood can affect the urban areas or the rural areas. So all of them are being used. The initial part of all of them is to create a watershed. So today we covered that part, that how we can create a watershed. Okay. So that is all for today. If you have any doubts, you can write in the comment box, and you can reach out to us. Otherwise, we'll see each other in the next class.